In this video, we're going to see factorization using algebraic identities 1. So in the last video, we learned an algebraic identity. A plus b whole square is equal to a square plus 2ab plus b square. So using this, now we can do the reverse. So as usual, we have always used to done like this. What is 4x plus 3y whole square? And we would use to write very simply that it is going to be equal to 16x square plus 24xy plus 9y square. And remember that whenever we do square of 4x, it's not 4x square is not equal to 4x square. These are not equal. This is actually equal to 16x square, so we should always keep this in mind. So now we're going to do reverse. Now we're going to be asked, factorize this. 9y square plus 18xy plus 9x square. So we can just do this very easily. So first we can see that this is 9y square, so you can write this as 3y whole square plus 18xy plus 3x whole square. So now we also need to check whether these two add up or not. So 3 times 3 is 9 and then times 2 is 18. So yes, this is correct. So you can write this as 3x plus 3y whole square. Just write this and this and we will get our factorized form. So this was not very hard. We just have to reverse the square root of these and check whether is this correct, because in exam we can also get checked. Suppose that we are asked 3x square plus 7x plus 1, and then if we were to just do this, let us imagine this is 9x square instead of 3x square. So we will just write here 3x plus 1, and you might think this is correct, but this is wrong, because we have to check in the middle that it has to follow this 2ab rule. So this does not follow the 2ab rule, so this is not going to be the answer, and we are going to, and this has another method that we will see later. So let us practice some questions. So our first question is, let us factorize 36x square plus 12x plus 1. So we can do this very easily. It's not going to be that hard. We just need to take the square root of this and then check this part. So let us write this square root of this. So we can write this as 6x whole square plus 12x plus 1 square, which is equal to 6x plus 1 whole square. And let us check if this follows the rule. 6x times 1 is 6x times 2 is 12x. So we can check this in our heads by this method. Let's do another one. 64z square plus 32xz plus 4x square. So we can write this as 8z whole square plus 32xz plus 2x whole square, or you can write these inverted. It's not this way usually in exams, but I have written it this way. So we can write this as 8z plus 2x whole square, and I think you get the idea on how to solve these. So now next step is to check whether this is correct or not. So 8 times 2 is 16, zx or xz times 2 is 32. So this is also correct. But we are not always asked like this directly. Now we are also asked something like this. So for example, we can be asked 72 x square plus 24x plus 2. Notice that this is just the double of this, and you might think that we cannot make the factor out of it, so but we can factorize it further, even if you cannot see it. So we can just multiply this expression by 2 by 2. 72x square plus 24x plus 2. So we can see we just multiplied by 2 by 2. So this doesn't change the output, but we can substitute this value. So this will get us 2. 2 times 36x square plus 24x plus 2, and then we can factorize this part, and then we get 2 times 6x plus 1, and with this is 1, so this is supposed to be 1, not 2. 1, and this will be our factorized form. So now let us do one more question like this. All we have to do is factor out the common factors. So now let us imagine that we are asked another one. Like, let us imagine that we are asked 28x square plus 84xy plus 63y square. So we can see one common term in here, which is 7. So we can multiply this by 7 and then we can write the same again, plus 63y square. So substituting 1 by 7, we get 7 times 4x square plus, dividing this we get 12xy plus 9y square, which is equal to 7 times 2x plus 3y whole square, and we can check it and we can see that it is correct. So our answer is found, and this was the way how to solve these kinds of questions. So thank you.